Now dear student, we are going to discuss question number 7.14, and in this question it is given to you, obtain the answer A and B in exercise 7.13 if the circuit is connected to a high frequency supply 240 volt and 10 kilohertz. Hence explain the statement that at a very high frequency an inductor in a circuit nearly amounts to an open circuit. Find how does an inductor behave in a DC circuit after steady state. Clear? Now you can say in example number 7.13, this is given to you as a information. We have connected here inductor and resistance, both are in a series. Value of inductance that is given to you 0.50 Henry, and value of R we have, this is 100 ohm. Clear? Now it is also given here, it is connected to a supply 240 volt and 10 kilohertz. Clear? So I can say if we talk about frequency, we can write like this is 10 multiplied 10 to the power 3 hertz. Clear? So from here we can say this is 10 to the power 4 hertz. Clear? Now our objective here is to explain statement that at very high frequency an inductor in a circuit nearly amounts to an open circuit. Clear? So first let us try to find here value of I naught, means maximum current. But before that you can see here we have we can say inductor and resistor. So if we draw here an impedance triangle, you can see let's suppose this is a direction of R. Clear? At the time we can say in this direction we have XL. Clear? So if I talk about impedance we can say this is given by Z, and that is equal to XL square plus R square. Clear? So let's suppose I am saying this is omega t. Clear? Or let's suppose I am saying this is representing a sinusoidal voltage, or we can say this variable voltage, this is V equal to V naught cos of omega t. Clear? Now we know value of I in the direction of this R. Clear? It means I can say I is also in the same direction, because in purely resistive circuit current is in the same phase as voltage. Clear? So I can say here we can write like this, I equal to I naught cos of omega t minus phi. Clear? So you can see here actually this current is lagging behind by a phase angle phi with voltage. Clear? So can we find here value, that is I naught. Clear? So I naught means we can say maximum value of current, this is given by V naught upon under root of, why I am saying under root, because we have to write here impedance. So value of Z, that is given by XL square plus R square. Clear? So from here I can write like this, value of I naught. Clear? Value of I naught, this is equal to V naught. V naught equal to what? This is 240. 240 is VRMS. Clear? 240 is VRMS, and I can multiply it with under root 2 divided by under root of XL square plus R square. Clear? So under root of XL. XL means I can say this is equal to omega L. Clear? So omega L whole square plus I can say R square. Value of R we have, this is we can say 100. So this is 10 to the power 4. Now we can see here, if we place here value, this is omega. Clear? So we can write here this value, this is equal to 240 under root 2 divided by under root of omega, we can say this is 2 pi f. Clear? So I can write like this, this is 4 pi square f square L square plus 10 to the power 4. Now listen carefully. In this question it is given to you, we have high frequency. Clear? We have high frequency means this is 10 to the power 4, and what we are doing here, we are doing here square. Clear? Value of L is given to you, that is 1 by 2, so this becomes 1 by 4. Clear? Pi square, this is equal to 10 and 4. It means you can observe one thing here, this term is actually very large compared to this 10 to the power 4. Clear? So now we can say here we can ignore term of resistance. Clear? So from here you can write like this, this is given by 240 under root 2 divided by 2 pi f and multiplied with L. Clear? So from here we can say this is given by 120 under root 2 divided by pi, I can say value of f, this is equal to 10 to the power 4 and multiplied with 1 by 2. Clear? Now we can solve it and we can find here value of I naught. Clear? And definitely you can see, if we just observe here magnitude of this current, it will become out to be very small. Yes or no? So from here we can say it will be turn out to be small. So directly you can say, because we are using here high frequency current. Clear? What we are doing? We are using here a high frequency current. So due to this high frequency current, we are getting this value I is very small. It means we can say at high frequency, this is actually happening due to inductor. So at high frequency, this inductor is actually blocking all the currents. It means I can say it is behaving just like an open circuit. Clear? So you can also understand it like this. Let's suppose I am saying this is equal to XL. XL is given by omega L. Clear? I can say 2 pi FL. Clear? Now in this question it is given we are using a very high frequency source. Clear? So when F is very large, I can say this value of XL is very large. Clear? So when value of XL is very large, it means I can say this is what we can say this is inductive reactance. Clear? This is inductive reactance. So value of inductive reactance is very high. Clear? It means I can say it will offer a more resistance. When it will offer more resistance, I can say the current that will flow, or we can say a very small current will flow, or we can treat this circuit as an open circuit. Clear to everyone? Open circuit. Clear? Yes. So one more question is here. How does an inductor behave in a DC circuit after steady state? So let's suppose we just started and this is LR circuit. Clear? Let's suppose now instead of AC supply, I am providing here a DC supply. So for DC supply, I can say value of I is a constant. Clear? Or we can say if we are talking about DC supply, value of frequency 0, because in DC we will not find number of cycles completed in 1 second. Clear? So I can say frequency is 0. So at that time, if I am talking about DC, for DC I can say frequency 0. So value of XL, this is equal to omega L, and I can say this is 2 pi FL, and this is equal to 0 ohm. Clear? So I can say value of XL is given by this is equal to 0 ohm. Clear? It means we can say if we are using here DC current, at that time it is just behaving as a conductor wire, it is offering no resistance. Clear?